Good evening, sir. My name is Aditya Prakash, and my team members are Harsh Ashish and Sharman Shaki. So our project is on hybrid crypto system for secure file transmission and preserve. And we have this is our abstract and introduction here. In this project, we have proposed an algorithm for hybrid cryptography, which serves as a reliable and secure way to keep the data uninformed to the intruder or any other outside middleman. The project aims to take the data as input and produce a meaning secure files which could be stored separately onto different geological locations and be safe. Why these files are accessed by the concerned authority of the system, calculation and manipulation are again performed with the help of a key from the file itself to produce the original data from normal use. This is probably encounter for online file transfer. What are the problems we have faced earlier? And these are all the real life cases which I have already explained you in the review two class. Review two. Then this is the equation that we derived from the research paper that we referred to, and using the Diophantine equation. Uh, then we have this algorithm here. So anybody here would like to explain this algorithm, please feel free to do
Yeah.
so.
Okay. So basically, sir, as we have mentioned, sir, we have derived a formula for according to which our files will be our files will get crypted and encrypted. And first, what's the algorithm is basically we first take the initial file which is to be encrypted. We read the file, and now based on the formula generated, we encrypt the file according to its number. Like each file has a unique number. So basically, two different files are generated, which is to be taken care of. Of course, two different files will be generated. One will be encrypted and one will be decrypted file. So, and also for the encrypted file, we have to get a key. So basically, this is the formula for the public key, which will be generated for the encrypted file. Uh, Also in the formula, sir, L1 and L2 are mentioned. Basically, L1 and L2 are CT1 and CT2, which is ciphertext 1 and ciphertext 2. Sir, after the key is generated, the file is passed through the formula for storation, and the key is appended to it. And later, when the files are required to be decrypted again, they are fed by the formula, and the key is applied to it. So basically, it gets decrypted. And so like this is the implementation which will be explained by my teammate Aditya Prakash.
So in this code, we have imported some libraries, random, OS, and time, and then we have imported a text IO. This code is actually in Python. Then this method we
These
have
are the,
used.
sir, input files. These are the input files, basically file 1, CT1 and CT2. The each file is just imported number by number. Aditya, can you move down? And so
Yes.
like this is X, Y, R, P, Q. These are the, sir, Diophantine. These are the numbers required to produce the Diophantine equation based on which our files will get encrypted. Sir,
That
as
equation
you
we
can
have already derived earlier. So
yeah,
go ahead.
we have made a function open in which in which we have given the input files, and we have given it a variable hg and j. So like there is also a function called process. So basically this is the main formula from the Diophantine equation produced, according to which the files will get crypted, ct1 and ct2 encrypted, sir. And after that, so basically the decryption operation. And can you move down, Aditya?
Yes, yes. This is the next
Sir,
thing.
and basically, sir, this is the code for our calculation of time, sir. Like with we have the main aim of this project is to, sir, like encrypt and decrypt a file, and also to get the encryption time and the decryption time in millisecond. So like how much time will it take for a file of what size to get encrypted or decrypted according to the Diophantine equation? Can you move down, Aditya, please? And so this is also the time. This is also the basically
Part of the process.
part of the time code only. So like the file is encrypted and decrypted. Like we are calculating the time here for encryption and
And the
decryption
last
only.
part, we are now decrypting the file that we have already encrypted to show that the file which we have encrypted is now retrieved.
Yeah. Can you
Okay.
Yes,
move
sir.
down, Aditya?
So these are
So
all the
these are the
screenshots.
screenshots of the code in the PyCharm. So we have
Uh,
used.
this is the file
So
that we have
like,
used here.
These are our outputs.
sir, as you can
These
see,
are
sir. as you can see, sir, basically these are the files which we have taken under consideration. These are the input files. Sir, random numbers are there in the file, as you can see, sir.
Random numbers have been
Can you move?
generated using
Yeah.
dot random something. Where this is the what? This is
These are the
also the
input
file
files.
that
These
I'm
are the
using.
input files only. These are the input files, and basically, you can you move down, please?
This
So,
is the
like,
final
this is
result.
the final result, sir.
These are the
Basically,
final
sir,
results which we have decrypted it, and we have taken out the time of encryption, decryption, and all
like, sir,
in
file if file
milliseconds.
size is 10 KB or 100 KB or 1000, depending on the processor speed and the RAM of a computer. So the encryption period and decryption period is calculated based on the code. Sir, these are the
Basically, we were
few of the
pointing out that as the
implementations.
file size increases, encryption time increases, as well as the decryption time. So
Yeah,
Yes,
this
it is
shows
directly
the
proportional.
yeah, sir.
okay, and this is the screenshot for file of size 10 KB. Then further down, we have the screenshot of file of 100 KB size. So as you can see, the encryption period is zero point 0.2 milliseconds, and then key is 431, the encryption key,
So
which
once
will
the like sir, once the file is encrypted, a public key is also generated using our algorithm, and so then the public key is appended to it, and then the file is decrypted, and simultaneously a code is there for calculating the period in which this all process is done, and that you can see the output here, sir.
this
Ditya,
is
can
the
you move down?
graph.
So like this is one of the most important parts. So like here we have shown the data time graph. So according to say like basically the data size and the time. So how much the time varies according to the size of the data. So with this we have shown in the form of a graph. So this was done on a quad core processor, sir, and 8 GB RAM, and this is the data produced according to that, sir. Aditya, can you please show the main implementation
Yeah,
on
sure.
PyCharm? Yeah.
Uh, just a second. This is the PyCharm
So,
code.
yeah, like, sir, these are the random modules we uploaded, sir, like imported. And, sir, basically, this is the main variable, sir. Like, we change the size of file from here. Like, Aditya, please make it to 100 KB. Just 100. So, whatever the value of W is here, it's in KBs, sir.
Do you want me to
Please
run it?
run it. Yeah.
Yes, sir.
So as you can see, the encryption period is very less for this. Now, Aditya, just make it 10,000. Yeah. Yeah.
So again, I got some output.
Sir, yeah, sir. Like the encryption period has again increased. Now let's increase the encryption period. Now let's increase the file size by used numbers. Yeah. Now run it.
So it will take some
So now it's
time
taking
as
time.
It will take time. It will take time. Let it be.
since the file size is very large as compared to the previous file sizes.
Yeah.
So we have received
Yeah,
an
so it
encryption
came.
period that is 8.5 seconds.
The file is still getting decrypted. I guess it's too slow right now. Yeah,
Yeah,
sir.
yeah.
So basically, this is what we have shown here. Like the file, according to the data time graph, also, sir. How much the sir for data, how much the file size increases, the time also increases.
The
It's
encryption and
proportional.
decryption time increases. Yes, sir.
Aditya, can you please go to the PyCharm projects folder where we have made the main project folder, please?
Yes, just a minute. Is this the one? Yeah.
Yeah. So basically these are the files which we have taken under consideration. So all the input files we as you can see, and from that we have produced our output, that encryption decryption times. Can you open
This is
cipher1.cry? So this
this
is
is
one
the
of the sir
encrypted file,
encrypted files. This is one of the encrypted files, sir. Like, sir,
and the output
sir,
file.
mainly, and the output file is here, sir. Like, sir, this is the numbers which were there in our input file. So this is what our project
This
is, sir.
is the end of
Mainly,
our project, and so we reached the conclusion that as you can observe from the above visualization, that if we divide the file into smaller pieces of or sub files, clearly we would be able to compute the things relatively faster with respect to the original file taken into consideration. This method can also be used as a hybrid crypto system, and various other derivatives can be taken into consideration for generation of various cryptographic algorithms and solutions. So this
Yeah,
was
that's
our
awesome.
project, and that's all.
Yeah, sir.
Thank you, sir.
That's all, sir. Thank you, sir.